In this video, we're going to design an MR2 headlight bezel for two circle headlights. Hey everyone, this is Matt with Learn Everything About Design, and this video is going to be a shorter version of the hour-long one that I put up for an MR2 headlight. The reason I wanted to make this video is because in the last video I covered a lot of topics, a lot of basics about the general process that you can use to design a whole range of products. So we looked at basics of things like extruding surfaces. We looked at how to use form body tools to connect to existing surfaces or solid edges. And then at the end, we did a lofted version between some existing geometry that we had. So that video has a ton of information. It's really long. And I think that after going through and recording that, I really wanted to make a more abbreviated version of how I would design this. Right? So I wanted to include all the ways that you could do it in the other video, but now I want to take a look at how I would do it in this video. So the assembly that we're starting with is still the same. We still have the headlight, the generic pivot that I created, and this goes up and down. So we're starting in the same point. I'm not going to go through all the nuances of creating an assembly component and doing all those different things that we did before. We're going to go into them here, but it's going to be a little bit different. So again, headlight component, we're going to do the DS headlight bezel, same way we did before. If you want more information on why I'm doing this, then I suggest that you check out the other video where we talk about some of the nuances that we're doing here. But we're going to create the DS headlight assembly. And again, at the top level, we're going to take the headlight, we're going to take the pivot, the DS pivot, and the bezel. We're going to drag them in here. Then we're going to select all of that, go to Assemble, and make that a rigid group, including child components, so that way everything still works as it should. So now that we have everything contained in this headlight assembly, we've got the headlight, the pivot, and the bezel. We're going to start working on the bezel. So in the bezel, I'm going to activate it, so I start working on it. And I'm going to hide the rest of the body for now, which is in the bodies folder at the very top level. It's called hood. We are going to come back to the DS skin in a little bit, but for right now, I'm going to just work from the top. So the thing that I would do is I would get started by creating a horizontal line, which is the plane for the headlights. We need to determine things like how long that is. In this case, I'm going to make it 180. Let's just do 180. That'll be okay. And I need to put it where I think the headlights should be. Now, this is going to be the headlight plane. Obviously, they're going to be facing forward. This is going to be controlling that. Then I need to determine where that location is in relation to something else. So I'm going to use P, which is project, and I'm just going to bring that vertex in. And this is going to give me a good reference. I'm going to give it a dimension. I'm going to say 35 millimeters, just because that's what it's close to already. And I'm going to give this one 10 behind that point. These numbers don't really mean anything. It's just giving me some grounding reference. Next, I want to take that and I want to extrude it between the DS skin, which is the down position of the headlight, and then I want to extrude it up to the headlight bucket. This is going to be a surface, so we're going to go to our surface tools. We're going to extrude that. We're going to change the start to object, and we're going to change the extent type to object. When you're rotating something and the coordinate system is way away from that object, while I'm holding down Shift on my keyboard and pressing down the middle mouse wheel, that green dot is the center of rotation. So if I click the center of where I want to rotate with my mouse wheel, then it's going to reset that pivot. That helps you, especially when you're doing objects like this. So again, surface extrude from the down position surface to the up position underside surface. This gives us our headlight position. Another thing I talked about was using extend. I'm only going to do this on one side. I'm extending perpendicular, and I'm just going to go back some amount, 180 in this case, keeping in mind that this is a single body. If we expand the bodies folder, two faces, single body. Next, I'm going to trim. Trim tool is the underside of the headlight bucket, and then trim tool here is going to be the down position of the headlight. So from the side, when we look at this, what we're seeing, if we bring back the hood, is we're seeing the headlight in its down position and its up position should exactly match that headlight surface. So if I didn't already mention, this is a 9195 MR2, second gen MR2, very smooth body, and we're working on the headlight bezel. So now that I have this, I can determine my headlights. Because this was an extrude from a straight line, I can just create a sketch directly on it. I'm going to use 2 circles, so C on the keyboard, and I need to decide where those headlights are going to be, if one's larger than the other, if I need any driving references for their locations. In this case, I'm going to go ahead and use my dimension tool. I'm going to make them both 50 millimeters. Seems like a good number. If we want to make these 2 dimensions exactly the same, we can link them by clicking on the first one. That way, if I change this one to 55 or whatever, then we can do that. You can also use the equal constraint as well instead of a second dimension. This can be helpful, especially if we want to control a lot of different things with a dimension. For example, if I wanted this one to be 5 millimeters smaller, I could just say -5. And if this one goes to 75, that one's going to be 70 and so on. So it can be a good way that you can connect these two. But I'm going to just go ahead and make them the same. I am going to have them at different positions. I'm not going to control their location with dimensions. Obviously you should, but I'm just going to go ahead and find the horizontal position. So I'm going to use a line. I'm going to find the midpoint here, and I'm going to hit a check mark. I'm going to find the midpoint over here, hit escape. I'm going to make that horizontal. I'm going to make this horizontal as well. And then I'm going to convert these to construction, which can be done in the sketch palette or X on the keyboard. All right, so now their horizontal location is fixed based on the midpoint of the plane or the face that we're working off of. The horizontal location I don't really care about. I'm going to make these 2 equal with the equal constraint, and I'll just give one a dimension of 50 millimeters, and that puts it in a good spot. So next, I need to get rid of those. So I'm going to use trim. My trim tool is my sketch, and I want to remove the center of that. You can see it turned red. I'm going to repeat that using this one, trim that away. There are other tools that you can use, split face, split body, but this gives me something to work on. Next, I want to hide that sketch, and I am actually going to use extend, and I'm going to extend a small section, 10 millimeters back. You can't do this. Sometimes you can't do this with 2 separate edges if they're not connected. Sometimes it won't like it. But this gives us basically where the headlight is going to go, some sort of reference here. That edge can help us drive tangency later on if we need it to. Okay, so now this is sort of the cage that's holding the headlight. While we're here, just to do it right, I'm going to go ahead and extend this back as well. I could have done this earlier, which would have allowed me to use the same trim tool at the same time and make multiple selections. But in the interest of speed, sometimes we sort of take shortcuts, I guess. Potentially not worrying so much about the modeling tree or the timeline or whatever program you're working in, but more on just getting the shape done. Okay, so now we have basically our headlight holder, the piece that's going to hold the headlights. I might want to add some mounting points. And again, I'm not super worried about the location. So I'm just going to go ahead. I'm going to say the outside here is 15 millimeters. Maybe we're using an 8 millimeter screw. And I don't really care what this is. I'm just going to pick a random spot and leave it there. Again, you certainly should use dimensions, but I just am not. And I'm going to make this come out to sort of just give me a mounting point out in space so we can see how we would do that. Okay, so now this is all one solid body. We still have a surface body behind all of this, but the solid body is this piece that I just created. Because it was a closed extrude, it automatically made it a solid body. That's okay, it all is still going to move together. It's all still in this component, which is a rigid group in the rest of it. So now we've got one mounting point. Again, we would likely have one on the other side. We've got the cage where the headlight is going to be mounted to. In reality, these headlights generally mount from the back. It kind of depends on what you're working with. This is going to be a rough approximation of something like the Rogue kit for the MR2, where you're converting to something that doesn't pop up as much, and it has two circle headlights instead of one rectangular headlight. So now that we have the basis for the cage that holds the headlights, we've got one mounting point. Let's look at how we would make the rest of this. So in order to do this, I'm going to hide the hood, and I want to create a copy of this surface because I want to hack it up a little bit. So with it selected, I'm going to go to Offset, 0 millimeters as a new body, and say OK. So this is my body 3. I'm going to select it. I'm going to call it DS HL Skin, and I'm going to call it Copy. And importantly, I want to make sure that I hide the original. Now you can see that the opacity is different because it's in the body that we're working on. And I don't really need to, but I could have done the same thing with this one here. So again, offset 0. And then now I can get rid of, or I can hide what is the DS headlight. And I don't even need to see the pivot. Let's go ahead and hide the pivot. And we're going to hide this pivot as well. So we're just working on the stuff that we have. So now here is where we need to be careful. This top section here, this is the underside of this solid body. Remember, we're not necessarily worried about the solid body. We're making the bezel. So we're looking at the surfaces for the underside of the solid body and the top side of the car. If we want to connect these two together, we can use the trim option, and we can say that this is our trim tool. We want to get rid of that. We could repeat the process saying the bottom is our trim tool, and we want to get rid of that. Now, unfortunately, Fusion 360 does not have a trim tool that allows us to do both at the same time. There are other programs like SolidWorks that the trim tool allows you to do what's called a mutual trim. I believe Inventor does this as well with surfaces, where you can select all the surfaces and then you can decide what to keep and what to remove, and even whether or not you want to stitch them together. This is not the end of our story, however. We need to be extremely mindful of the fact that this edge does not end at the same place as this edge, because that's going to cause us problems. So what we want to do now is we want to trim, or we want to be mindful of the fact that we need to be aware that these do not end at the same place, and we need to fix it somehow. So when we look at this from the top, let's go to a top view. You can see that the car surface, the one on the bottom where the headlight is, that one is further out than the actual underside of the headlight bucket. They're at a slightly different angle, so you can see that they end at a different place. So it is going to be potentially problematic. When we have headlight bezels for things like these pop-up headlights, they don't perfectly match the body. There will be a gap there, of course. And those gaps, or reveals as they're generally called in plastic design, injection molded plastic parts, we can use those to our advantage. We don't have to have a perfect intersection between those. So what I'm going to do is I'm going to create a sketch on the top plane. Again, our coordinate system is sort of way out in space, but that's okay. And I want to figure out a solution to this problem. And my solution to this problem is going to be to select this top face and project it, P on the keyboard. And then I'm going to offset it in slightly. So I'm going to take this, I'm going to offset it in, let's go in -3 millimeters. And you can see it's giving me a warning. It didn't like that, but it still produced it. And then I want to take this outside and just convert it to construction. So I'm going to use X on the keyboard, making sure that I select everything there. All right, so now we've got body 1 or body 4. I'm going to hide that. That body 4 is the headlight, the underside of our headlight in the popped up position. And what we want to look at is we want to make sure that this sketch completely goes inside of the car headlight bucket. And it looks like it does. So I'm going to finish sketch, and I'm going to use that as a trim tool. So if I say trim, then I need to pick the pieces that I want. And the important thing here is when I select this, you can see the entire outside is red. If I bring this over, the entire outside is red. So that allowed me to cut this entire thing with an offset from the top. But it is an offset from the top, so we need to use it as a trim again. We're going to trim that, and we want to get rid of everything on the outside of this one. So now what we have is a top and a bottom that should exactly match. They don't necessarily have to touch. They're not stitched together, but they should exactly match. And that's what we're going for. All right, now at this point, let's go ahead and create a loft. So I want to use the Loft tool. And I'm not necessarily concerned with doing the entire loft in one go, but I am going to grab these two edges and then hit the plus to create another one. And I'm going to do the same thing on the top, just those two edges. You want to make sure that you aren't using chain selection. If you have that turned on by default, then it's going to try to go all the way around. So the first profile at the bottom, I'm going to use tangency. I'm going to take this handle, I'm going to drag it in, and this is going to give me a nice smooth transition. The top, we don't necessarily need tangency, but let's go ahead and try it and see what it looks like. So instantly it's trying to go outward, so we're going to drag it inward. This is probably going to be problematic at the value it's trying to give. You can see it's putting a number on the screen of 50. 50 is going to be too much, so I'm going to drag this in. As we do this, that number is actually changing the weight. Now it says 10 on the screen, but it's essentially determining how much influence that surface is going to have. So I'm going to change it to a much smaller number, let's say 0.5, and see if that gets us a little bit closer. So it's not liking the top. It's giving me a warning that it's going to be invalid because it's likely going to intersect itself. We can get away from this by excluding some of these edges. So if I hold down Control and get rid of those, you can see that we can create this sort of this tangency. I'm going to go back and note that we've got free edges, align edges, and then align to surface. Those edges are going to basically be created, that's this open edge here. It's going to be created based on our selection. So let's pay close attention to what happens when we change that. Free edge, you can see, is based on the geometry. We're going to align to the edge of our surface, or we're actually going to align to the surface itself. If we're planning on carrying this curvature back farther, then we want to use that align to surface. Profile 1 is on the bottom, and this is really the one where we want the curvature. I don't really care about profile 2. I'm going to potentially leave it connected, but I'm going to use the curvature at the bottom because that's really where we want to match the shape of the car. And then the rest of it really is just going to be a big flat brick. I mean, that's the intention of pop-up headlights, is to get better aerodynamics when they're down, not really when they're up. So we're going to go ahead and work with that. We're going to say okay. And then we're going to try to carry that surface back as a loft. We could do this with other tools, and we're going to explore those other tools. But I'm going to try to loft the back edge. So we're going to go from here to here, no tangency or anything. And then we're going to try to use a patch, and we're going to see how that works. Again, turn off chaining. We're going to manually tell it exactly where we want it to go. And we're going to zoom in and grab that tiny little edge at the back. So on the front edge here, we need to find that, which is edge 2. We want that to have tangency. We want to carry this curvature back. If we want the curvature to happen on edge 1 as well, we can do that. But notice that it doesn't like it. Now, there is actually a weight here. There's a number that we can enter. I can make that value 1.0 if I want. And we can control that curvature back. But you'll notice that it's really pushing this in quite a bit. It's not giving us the shape that we're looking for. So I'm going to cancel this, and I'm going to retry that using a loft. I'm going to go from this upper edge to this lower edge, but this time I'm going to add a rail. I'm going to use this as a rail. With the rail, we want to carry that tangency. We can also explore curvature, but what curvature is doing is it's not only taking the direction of the influence, but it's also taking the weight. So since we're rolling around a curve here, it's going to be pretty drastic, and you saw how it sort of pushed that in. The top, we're going to stay connected. Profile 2, if we put tangency on the bottom, we can change that weight potentially, but we have to be mindful when we change the weight of things like this. What we need to be mindful of is what the weight of the original edge was down here. Otherwise, we're going to be pressing those surfaces in ways that they don't want to be pressed. We can try to grab these and pull them forward. It doesn't always work. Sometimes it works better than others. But, that looks okay. That looks pretty good. We're carrying the curvature of the surface. I do want to make a quick note that what we're doing here is not necessarily best surfacing practices. There is more that we can do, but we're just looking at the general process. I'm not spending a lot of time actually worrying too much about the underlying curvature that's happening here. And part of the reason is because of time. Just quite frankly, it takes a lot of time to do something the right way, and you guys probably don't want to watch hours of designing this part. So hopefully this just gives you a good idea of a way to design this thing. So again, we're going to loft this. We're going to add this as a rail. We're not worried about curvature here because this is a sharp corner. It doesn't have a fillet or any blend. And we're going to just say okay. So now what we've done is we've created this sort of outside shape. You can see that here's our mounting boss. We'll worry about that in just a little bit. But now we want to stitch these three together. Now this bezel is only going to be on three sides. The green edges are where it's getting stitched, and we can say okay. So now we've got this body that we just created. I'm going to rename this bezel in here. These other bodies, this back one was just sort of used as containment. The top and the bottom aren't really necessary. If we bring back the driver's side skin and the hood, and we bring back the rest of our headlight, the headlight here, you can see from the side that this piece looks pretty good in terms of the curvature. It still moves up and down, slots into place, and that's what we would expect to see. What we haven't done yet is we haven't attached it, and we haven't accounted for the headlight themselves. Okay, so there's still a lot that we need to do. We're going to get to it. So let's make sure that we hide the headlight. And then I want to bring this sketch forward. So I'm going to right click. I'm going to create a sketch on that face, which automatically gives me these references. And then I'm going to draw bigger circles. So I need to draw the circle that I want it to attach to. In this case, I'm going to say 95 millimeters there. I need to find the center of the other one. This can be kind of hard to do because we can't see it. So we might want to hide our bezel. Then we can easily find it. So this is going to be tricky because these two are likely going to overlap. And we need to decide if we want them to overlap or not. So I'm going to make the dimensions the same. And then I'm going to play with these dimensions until they don't overlap. So let's try 85. Gets us pretty close. 80 is the magic spot where they don't overlap. All right, so now that I have this, bring back my bezel, and now I want to trim it. So trim tool, get rid of that, say okay, right click, and I'm going to repeat the trim tool, get rid of that. And again, we might need to rotate it to make sure. Also note that the right click marking menu has okay and cancel on it. So again, once you get comfortable with that right click menu, it can be pretty fast. Now we want to create the surface that goes back to the headlight. We're going to do that with a loft again. Loft is a really good surface tool. We're going to go from here to here. Profile 1, we're going to try to do tangency. And you can see that it's yellow. It's telling us that it's self-intersecting. And a lot of times this ends up happening depending on where these points are. Sometimes you can rotate them around. And a lot of times what ends up happening is when we have a complete profile like this, it really has a hard time controlling the interface between where to start and where to end. And the way that we get around that is by splitting this up. Now, generally when you split something up, it's because you have symmetry. We don't have symmetry here. So in order to split this thing up, we're going to, again, sketch on that front face. We are going to find the center point. And I'm going to just draw a vertical line. And I'm going to draw one down as well. I'm going to do the same thing over here. And the trick that I'm going to use here is I want to connect these so that they're one closed sketch. And then when they're one closed sketch, we'll be able to just select it as one. So I'm going to come down. I don't really care if they're perpendicular or parallel. I just want to close sketch. And now I can use this to split the face. So I want to split this face and this face back here. My splitting tool is the sketch, which is closed, and I can say OK. So now you can see that I've sort of broken this up. And the reason I've broken this up is because now when I go to Loft, I go from here, and my second profile is going to be to here. Now you'll notice that it also broke it up sort of in the middle. That does happen sometimes, but you can see here now we're sort of getting that loft from the profile. We can manipulate the values, we can align to specific edges, we can control a tangency or curvature, and then this gets us a little bit closer to our goal. Now, profile 1 is tricky because if we say tangent, we don't know if it's tangent with this surface or if it's tangent with this surface. So a lot of times what'll happen is we can we can flip the direction, the orientation, we can manipulate the edges that we're using, but sometimes we actually need to create a potential change in the tangency. So you can see here, we use this tangency direction, which wasn't available before because we didn't have an edge that contained two surfaces. So when we look at like profile 2, that option doesn't appear, and it doesn't appear simply because we don't have two intersecting edges. So keep that in mind. If you see that and your curvature is going the wrong way, you might be able to change it. All right, so I'm going to do this at, I think 1.5 will be okay. And you'll notice that it caused an error. It didn't create that for us. So unfortunately, that does happen sometimes. Let's give it another shot and see if we can potentially get it on the other side. Go from here to here. Second one, we're going to do tangency. Notice that it's really failing in the middle because it just doesn't have the curvature. So one way that we can get around that is by creating a sketch to help drive this. In this case, I'm going to, again, align to surfaces. It gives us a little bit cleaner look. And the bottom one seems to be okay. If I apply tangency, change it, that looks like it's okay. Next, I'm going to do, let's go ahead and let's try to do a patch. So again, make sure that enable chaining is turned off. Enable chaining works great if you have a closed set of edges. Things are all stitched together. In some cases, it works okay. Edge 1, we want to at least have tangency. Edge 4, we want to at least have tangency. Edge 2 and 3, we want that tangency as well. And we're going to say okay with that. So you can see that we've got this nice sort of smooth transition. We are going to do a little bit more in the middle here, so don't worry about that just yet. Let's carry over and let's loft. Let's try this side. We'll go from here to here. Again, profile 1, we're going to do tangency. Profile 2, we'll do tangent. If we need to, we'll flip the direction. We're going to make sure that they align to surface, and we'll say okay. Once again, there's some sort of funkiness that's happening in the middle. A way that we would get around that is by splitting this up again and potentially doing it in smaller sections. We could do that with this loft because it did automatically break that up. On this side, at least, we could do that. But here, we would have to do some more to break it up. And honestly, the result is probably not going to be that much different for what we're doing here. And I'm going to say... Oh, actually, you know what? We didn't loft that other side. We did a patch. Let's go ahead and do the same thing again. Enable chaining's turned off. 1, 2, 3, 4, 5, and 6. So another thing that we can do is we can say group edges. If we want them all to be tangent, for example, we can group the edges together. This doesn't work because in this case, edge 1 is connected to the wrong surface, and it looks like, let's see, edge 2 is also connected to the wrong surface. So it's having problems at the bottom, but that's okay. All right, so now we've got sort of that smooth transition. Again, the surfaces were not very happy here. I'm not too worried about it. That's something that we could fix. But I want to show you how to blend these two together. The first thing that I'm going to do is I'm going to stitch it all together. I'm going to take that. I'm going to take these surfaces here, and this is going to turn them into one surface body. And then I want to figure out how to create a blend between these two. And I need to do this by first creating a sketch. We could sketch on this plane if we wanted to, and I'm going to go ahead and I'll just use that. Then I need to determine how I want these to interact. I'm going to start by projecting some of these edges. Just, again, P on the keyboard. And then I'm going to draw a line between them. I'm going to do the same thing down here. And this is going to represent sort of where we're going to trim. The next thing I want to do is I'm going to use an arc to go from here to here. I'll do the same thing over here. We could spend a lot of time figuring out how we want to split these up, but this is just sort of a quick demonstration on how we can do it. Then we can use the trim tool, and the trim tool is going to be this guy. And then I want to decide what to remove. I'm just going to pick this inside section here. I want to make sure that the trim tool stays and then the surface is selected. You'll notice it keeps trying to select that, that inside section as part of the trim tool. So you might need to come at it from a different angle. If you have trouble based on these surfaces, we can always use things like extrude or potentially split face. So the faces to split are going to be these, and the splitting tool is going to be that sketch. We'll say OK. And now this gives us some surfaces that we can select and we can delete. And then we can use our patch tool. In this case, we'll enable chaining. We'll let it grab the entire thing. We're going to group them all together, and we're going to tell them that we want curvature. And you can see in the middle, it sort of falls apart. We can try tangency, see if it's a little bit better. It looks a little bit better, but let's just not get focused on the quality of these surfaces. Just understand the process. So at this point, this is not a best practices of surfacing, but this is a how can we break these up so that they look more organic. We're going to stitch them back together, and that looks like all of it. We're going to say OK. Last thing that we want to do is we want to figure out how we can attach to the mounting boss. So I'm going to do this by creating an offset of the mounting face. I'm going to say OK, the offset is at 0, and then I'm going to hide that solid body. So now I have a surface that represents that mounting boss. Then I need to figure out how to take it out to the surface that I want to mount to. So this is going to be tricky because it's actually split into two. And the way that I'm going to approach this is I'm going to use a split face. My splitting tool is going to be this organic surface, and the face to split is that mounting boss. So now I've broken it up into two. And the reason that I've done that is because now I can extend this. Again, tangent chaining is not our friend here. I'm going to turn that off. I can extend this one back, can repeat the process, and this time I can extend this one forward. Important thing is to extend it all past where we want to go. Now we can use our trim tool. We're going to use, in this case, let's get started by using this. And we're going to use this as our trim tool. And we want to remove that section of our organic part in the middle. Once we remove that, we're going to repeat the trim tool. But this time we're going to use our organic surface. We're going to get rid of this piece and the piece on the inside right there. And now we can stitch those together. So this body and this is all one body because we used the extend. And now we've created that sort of mounting boss that sort of fell in between that weird curvature. If we bring back the solid body, it's going to perfectly align to that. And we could obviously do more work blending all this stuff together, but that gets us a good start. So this is the general process, right? So you have to put a lot of time and thought into what you want this to look like. But this is the general process that I would follow using surfacing tools. So I would spend a lot more time breaking up the faces and making smaller sections that have the curvature that's exactly what I want. And then spend the time with all of those details. Like we did some big, broad surfaces to get this to work. That is not the way that I would do it. I would break it up a bit more so I have more control over smaller sections. But that is the process. So hopefully that process helps and gives you a good starting point. At this point, this was over 30 minutes into this one, but this will give you a good idea on hopefully how to go about the process. If you have any questions, any hangups along the way, please let me know. The original video had a lot of tips on different ways that it could be done. This one was focusing more on the surfacing tools, on how I would approach the process. Again, something like this to get a detailed part that I would produce would take several hours. I mean, it's not a quick process. You can get the basics, the general shape down right away, but then to get past that, it's going to take a lot of time. So just keep in mind that it's not a quick process. It's going to be if this was a production part, and by production I mean something I would 3D print for my own car, I would likely spend probably somewhere between 20 and 50 hours making sure that it was perfect before I ever made a part. So it is a good time investment to make something like this. But again, if you have any questions, please let me know. Hopefully this was beneficial to you. I know it was a bit long at this point, over an hour and a half of content just on a headlight bezel, but hopefully it was helpful to somebody. And if you have any questions, obviously let me know. Thanks for watching, and see you in the next one.